Hi, I'm Matthew Adams. I'm a developer at Wolfram, and I'll be talking about the state of graphics in the cloud, specifically giving an overview of our next generation graphics rendering system.
All right, hi, I'm Matt, and I'm going to be telling you what's up with graphics in the cloud. This is going to be, John mentioned native graphics. This is going to be a very native graphics-y talk, so I see a couple of you that already know what that is. Fair warning, that's what I'll be talking about. So here are the questions we're asking today. This is the standard middle school birthday party invitation questions. What, why, how, when? What is native graphics? Why are we building it? How does it work? I'll get into some nitty gritty details there. And when are specific features going to be supported? So first, what? It's our, as John mentioned, it's our next generation graphics rendering system for cloud. It's a complete re-implementation of cloud graphics. And we're just incrementally replacing our old rendering system. So if you render graphics in the cloud today, they're both working. If a graphic is supported with a new system, it'll be rendered with a new system. If it's not, then it'll still be rendered with the old system. So this is something that end users don't have to think about. If you're a power user, you're really trying to optimize your graphics for cloud, you might want to think about it. Take advantage of some of the features of the new system. Why are we doing it? Well, it's a comparison with the old system here. The old system is good enough for most use cases. I mean, obviously we've had graphics in the cloud for, I guess since the beginning, I assume. and it works great for many use cases. But there are a few limitations, and native graphics completely addresses that. So if something's supported in native graphics, it should match desktop Mathematica. The old system, which we call helper data here for reasons that I'll explain later, is generally slower. And there's some more moving parts just by the nature of the design of the system. So just from a software engineering perspective, the native graphics system has fewer bugs, or is less likely to have new bugs. And the old system also requires a network for every render, which is maybe a bit of a subtle point. But the new system works entirely in the browser, which opens up the possibility of lots more performance gains, even beyond what it's giving us now. I'll dive into that a little bit more too. And of course, the old system, the big advantage is it can render any graphic. So it's giving you everything. And the new system is we're slowly adding features, incrementally adding features. So some more specific improvements that we get from native graphics. I have this hacky helper function here just to force things that would normally be rendered natively using helper data just for the talk. Dynamic inside graphics is one limitation. So here we have, I'm forcing this graphic to be helper data, and it has a dynamic radius. But this actually isn't supported, so I'm dragging the slider, the radius isn't changing. Here's the same thing, native graphic, same thing with me misclicking native graphics version. And you can see now that it's supported. I should add that with helper data, if you want to do something like this, there's the easy workaround of making the entire wrapping dynamic around the entire graphic. So you see with helper data, this does work. Although you can see even from this example, maybe there's some lag on Zoom, but the helper data graphics is visibly slower than the native graphics case. Yeah. If you, there it is. This is the inside of cloud. I'm not supposed to see this. Pardon me? Oh. Cool. And I actually have some graphics that I'll revisit that question when we get to those graphics. So more advantages of the new system, gives us correct behavior during manual resize. Oh, I thought I saw a hand back there. So we can see with this example, I resize it, and then when I let go, it snaps. This is because the disk is supposed to be offset coordinates, which is supposed to hold a consistent size, but the limitation of the helper data system, it doesn't know that, so it only updates after you release. Whereas native graphics gets the same behavior as desktop, even down to things like when it gets small, it changes the aspect ratio, that sort of thing. And then there's no snapbacking effect. This can get complicated. This is an extremely contrived example, but I worked really hard on it, so here it is. You see when it resizes, it's a case where these points are sort of racing each other, and it changes what shape the graphic ends up being. So that's helper data snapping around. Native just works smoothly. You see the aspect ratio changing as it gets smaller, and which points to sort of determine the boundary of the graphic. And that exactly matches desktop. Similarly, the native graphics helps us get rid of just little bits of jitter. So if I evaluate this, I don't know if that's fast enough on Zoom. You can see when it pops in, it like pops a little big for a second and shrinks. That's just part of the nature of the system, where in this case, it's inside of a list, which makes graphics smaller, extra trip to the server to get exactly the right image size. So that kind of thing is avoided with native graphics. These are small things, but they sort of add up to a more cohesive, smooth experience when you're using graphics in Cloud. A big one, of course, is performance, John mentioned. This number should be taken with a huge grain of salt, but just to throw some data at you, here's an example of the manipulate that has 1,000 random circles every time you move the slider. It's just sort of a stress test case. And you can see the native graphics is roughly 35% faster here. Again, depends hugely on the network connection. I'm inclined to think this is more of a lower bound, but yeah, as I should mention earlier when I was showing that latency, I'm running on localhost because I'm actually running a feature branch to show you stuff that isn't released yet. So there's no network latency, and you can even still see the performance improvements with the slider I was pulling. One other benefit is integration with other parts of the notebook. I meant to put these in a different order. Magnification, that's external to the graphics. Certain types of magnification don't apply in helper data, but then they do in native, so half size. And then there's other strange cases. So here's a case where I'm resizing the outer box and the inner content depends on that size. This seems contrived, but actually comes up enough times that we're looking forward to being able to deliver this improvement. You see where native graphics is, the hello is scaling with the graphic as it's supposed to do. And one other last thing that's kind of small, but is a nice sort of quality of life thing, is if there's a user error, like you tried to center the disk on foo, helper data graphics will try to render something, and native graphics will give you pink box that is probably extremely small up there, but with a message center coordinate foo should be a pair of numbers, which is fairly polite given that you tried to center it on foo. So our next question, how are we building it? To discuss this, I first want to make sure we're all on the same page about how graphics are built in general. Talk about the anatomy of a graphic. Nice, perfect 10. That's what that sign is, right? Thank you. So building up a graphic. Here I give a completely empty graphic. Very exciting. And even though it's complex graphics in Wolfram Language are built out of these small building blocks put together. So here's a line. It's going from the origin to 1, 1. Let's make the line more interesting. I've got a table of some points here. So the X will be an X value and the Y value will be a sign of that value. So that'll give us a nice blocky curve. Of course, we can increase the resolution by just adding a bunch more line segments. This is still a line. It's just like a bunch of tiny segments to make a smooth curve. Of course, we can style, and some of you probably see where I'm heading with this. Pick a lovely blue color, make it a little thicker. So we have directives, we have primitives to be able to, for the building blocks, we have directives to style those primitives. Then we also have options, of course. So axes true gives us axes. And then it's just one more piece. I'm going to add this aspect ratio option. And now we've just recreated plot of sine of x out of these building blocks. And so any graphic that you're using, whether it's something like plot, whether you're doing graphics directly, whether you're doing contour plot, whatever, all our nice charting functions, it's all built out of these like small components put together. Oh, Zoom is not happy with me. Go away. All right. Pardon me, did I skip a slide there? No, okay. So how are we drawing all these pieces, drawing all these graphics? We need two pieces to do this. These are two black boxes, literally. Rendered with native graphics. I know that's an impressive graphic there. We take something to go from the input to a precise drawable description that's telling you like what numbers there are, what's where exactly. And then another piece to go from that precise representation to a actual rendered graphic you can see. Of course, I know you know, on desktop, these pieces are the kernel and the front end. And that intermediary is the Wolfram language, the box language, that everything in notebooks is sort of built around. So I'll turn this sideways. Yeah.
Yeah.
Yes. All right. Boxes. Yeah. Yeah. This is okay. This is a whole.
Plain faults way over there. It's probably too much. Sorry, go ahead.
Oh no. I was trying to think of a joke. So yeah, here we're looking at graphics in desktop. You see user enters in their input. The front end doesn't know what to do with the graphics disk, but or plot or whatever you're sending. So it passes along to the kernel. The kernel gives us this box language, which I'm sure is really hard to read. Graphics box, disk box, centered at 00, which goes back to the front end. And the front end does know how to speak the box language, and it can draw your output. Yeah. Yeah.
You can still do the keyboard shortcut, and there's also the cell gear menu allows you to show expression.
Yeah, if I wanted to do this one, I can Command Shift E.
Unlike the desktop, you can't edit it, but you can see it.
Yeah.
Oh, I see. How did you get to that?
I clicked on this bracket and did Command Shift E.
And there's also
I think there's also a menu here. Where is it? I never used that.
convert to, I think, this is bad. Okay. Maybe advanced. I think it's.
Oh, advanced. Show cell expression. There we go. It's advanced.
Definitely some UX we need to improve there.
Yeah. I feel like Command Shift E is just intuitive. I don't know. So let's talk about how we're bringing this to cloud. A little bigger. So now in cloud, of course, it's all on the server. And this is where I was thinking about your question. You can send, you see it sends to the server. The server coordinates this communication between the kernel and the front end. And this is the same, essentially the same kernel and front end that's running on desktop, but it's just running on our machines. So it, sends it over. Kernel still gives us a box expression. And for helper data, we use the front end to generate a different sort of intermediate, like precise numerical representation of the graphic. And that is the thing that we send down to the browser and we draw from that. Sometimes that is, yeah, I apologize. I see people squinting at the, the tiny text here. that is sometimes it's a image, sort of like PNG data. Sometimes it's something close to SVG data that we then render. Now, native graphics eliminates the server-side front-end piece. Oop. And then just uses the box language directly. So it's taking that front-end piece, re-implementing it on the browser, and that is sort of where all of the benefits I talked about fall out from. Which brings us to the last question: when our specific feature is going to be supported. We have some things fairly exciting, if such things are exciting to you, coming to native graphics. One of the big headliners is inset. You can put some other arbitrary content into the graphic. So I'm actually running on the inset branch right now. You can see this working, where it's you can position it relative to some anchor point. We also have axis object built on top of inset coming, and those two together are going to get us to list line plot pretty soon. We also have some more things in the pipeline. Everything on this page is in code review right now, actually. We have polygon without holes, filled curve and join curve, so more primitives you can build with. More interactivity. Locator is also coming soon. I should note locator pane is already supported in both helper data and native graphics. Locator is not supported in helper data and will be supported in native graphics soon. And some more of the fundamental options here. And of course, we have plenty of things already supported. This is the list of things that's working today. And we'll spare you reading out every single one. But it's worth remembering when talking about what's supported native graphics, it's what pieces are supported. Is line box supported? It's a box structure level thing, rather than is graph supported? Is a specific charting function supported? Like, well, does that charting function generate supported box code? Is the question there.
You have like a public objects that is
No, we should. You can have this exact list that's on the slides, unpathable. And we are working on a what do you call it? A resource function, Wolfram function repository, where you can evaluate a graphic and it'll tell you why it is or isn't supported. So you can then use that as a tool to tweak your graphics. Like, oh, maybe it's using some option that I don't actually care about, or I could accomplish in a slightly different way or something. No, because it's not up yet, but oh, okay. Right. So yeah. So let's wrap this up here. State of graphics in the cloud. We're progressing with our next generation rendering system, native graphics, inset, axis object, plot, and more coming soon. And of course, we're continuing to improve the reliability and performance and fix any bugs that come up for the helper data rendering system. So we're not just abandoning that. Trying to make everything work well for you. And come back to the questions at the beginning. They're answered. What is native graphics? Full graphic support implemented in the browser. Why? It's better. How? I just told you. Re-implemented in the browser. And when are specific things going to be supported? And we were just talking about that. If you have something that you like, ooh, if only this was natively supported, this would really help me out. Come talk to us. We can try and incorporate that when we're prioritizing. The only question I left out was who, of course. So here's a big thank you to everybody on this list here, especially Mate, who did a good portion of this work. There we are. Any questions? Event handler is on the list for native graphics, but isn't supported yet. And there's some parts of event handler that are supported in helper data, yeah, but not all of it. Right now, 3D is a separate animal, and Yeah, I
So
guess we're good. Thanks for listening.